Good news, everybody. I'm doing another symbolic logic video. This one is on exercise 3.10 on page 52 again. And just like we're going to go through and is sort of intuitively check for the validity of this argument. And then again, I chose it because it seems intuitively really weird. By the way, I apologize that the audio and video in the last video were very out of sync. In this video, I'm using Sound Recorder from Windows instead of Cam Studio's native sound recording, so hopefully that should make it a little bit better. So, first things first, we have 4 atoms here, and they're if-then statements in the premises. So let's symbolize these atoms. We have if Josh works hard, if he'll be able to buy a car, if Emily studies hard, she'll be able to get a degree. Therefore, if Josh works hard, Emily will be able to get a degree. Or, if Emily studies hard, Josh will be able to buy a car. Wow, that sounds crazy. Like, I don't think anybody would hear that and think that that argument is valid. They'd be like, well, what does Josh working hard have to do with Emily getting a degree? But let's check. Let's see. I actually don't quite remember whether this is valid or not, but it's entirely possible. So P implies Q, working hard implies car, and R implies S. Therefore, P implies S, or R implies Q. And now that we have it in symbolic form, it might be a little bit easier to think about, because we realize that it's not really saying that Josh working hard has anything to do with Emily getting a degree, or vice versa. So let's think about it. If Josh works hard, he'll be able to buy a car. And if Emily studies hard, she'll be able to get a degree. So for this connective to be true, it cannot be the case that this is true while both of these are false. So either the antecedents of both of them are false, or the consequence are true. So in the case where they're all false, then in the case where all the atoms are false, will it be the case that either P implies S or R implies Q? Well, actually yes, because the wedge here isn't talking about any of the atoms in particular, it's talking about the horseshoes. So it's saying that the truth table for the horseshoe it is what it's dependent on. So if the horseshoes are true, then the whole argument will be true. And similarly, let's say that Josh works hard and gets his car, but Emily does not study hard and does not get her degree. So if P and P and Q are true, but R and S are false, then, well, P implies S is going to be false, but R implies Q is still going to be true, because this will be false and this will be true, so the truth table still holds, as long as there's no case where R would be true and Q would be false. And I think if you think about it a little harder, you'll see that it's probably valid. Actually, it's definitely a lot more likely to be valid than we initially thought it was. So let's actually test it out. Let's go through all these yummy propositions and chew them up and spit them out into a truth table. And again, just as in the last video, we have 2 to the 4 rows, which is 16. And we have to have 8 zeros and 8 ones for every atom of the argument, because we're testing the validity given all of the states of truth of the proposition. This last sentence is kind of nasty. Let's fill in the wedge. No, actually, no, we won't really know how much room there is. So let's just do, therefore, if Josh works hard, P, Emily will be able to get a car. Emily, sorry, will be able to get a degree. And Emily studies hard. Josh will be able to buy a car, which is Q. And we'll put brackets around both of these, and horseshoes in there, and a wedge in here. And this, as hopefully we know by now, is the main connective. Wow, that is a very bold square. This is the main connective of the conclusion, and that's the one that we care about. The truth of the main connective in the cases where both of the premises are true. So let's, as quickly as possible, because the last video ran to 20 minutes, throw in all of the values. And I wish I had something to say while I was doing this to make it a little bit less boring, but sadly I don't. So there's our first atoms in there, and then we're going to get more atom values. So we'll just fill in all the same ones. It's not rocket science. It's not even atomic science. These are just logical atoms, not physical atoms, which would be much more tricky to work with, as anyone who's ever studied chemistry or physics knows. lose track of things a lot. I don't actually know how I managed to do so well on the test, not because I don't understand the material, but because, evidently, I often make silly errors, but I guess I always catch them in time. And hopefully you'll forgive me for wasting your time with these errors, since after all it is a free service and it's a YouTube video, so you can just skip ahead to where the errors are corrected and the values are all filled in. If this is boring the crap out of you, which it probably is. I know that my random commentary while I do this is not that amusing. So now we have our propositional values all pulled across, and it's just a matter of evaluating the connectives. And here we have a lot of connectives. We have 5. So let's see if we can do this really quickly. So for the horseshoe, we know always that if the antecedent is false, or if the consequent is true, then it's true. Otherwise, it's not. So we can just look at all these. The antecedent is false right away. Bang, 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 bang. Oh, here we go. Bang, 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 bang. The antecedent is false. It's true. Then we say, well, no, the antecedent with a true antecedent with a false conclusion, a bunch of rows, but then we have they're both true, which is great. Same thing here. It's antecedent false, 1, 1. Antecedent true, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1. Excellent. And then we have 2 more horseshoes. P implies S. So all of these will, because P is false for all of them, they'll all just be 1 again. And then these we'll have to test. And they're true only when S is true. Same thing with R. 1, 1, 1, 1, 1. And then 0, 0, 1, 1, 0, 0, 1, 1. Excellent. So now we can get to the main connective of the whole conclusion. And as long as either one of these is true, then we'll fill in the main connective as true. As long as either of these horseshoes is true, then we can call the connective true. So it's 1, 1, 1, 1, 1, 1, 1, 1, 1. 0 there. Both false here. 1, 1, 1, 1, 1. So there's only one row where the conclusion is false. Now let's take a look at the premises in that row, because if you remember how premises and conclusions work, the only way for the whole conditional to be false is if all the premises are true while the conditional is false. So let's just isolate this one row that we care about and look at its premises. And we will very quickly see that the main connectives 0, so are true here while the conclusion is false. So there are no counterexamples, and this argument surprisingly is valid. Thanks for listening.